Good morning. So here we are. It is Tuesday, the 1st of June. Ladies and gentlemen, we are rapidly nearing the end. And today we have a little bit of a weirdness. Purple Day today, we'll get the chance to work on this lab during their lab bell. White Day, weirdly, we're not going to get the same chance. I will try to give you time for it later in the year, but because it's a 4-day week, we gotta go. So this is going to be kind of a bonus lab, an extra lab, a fill-in lab in case there's another one that you're missing, something like the pig dissection. So let me show and explain to you how we do the Loop Lake lab. Now, if you follow along on this, then I will cover almost the whole lab for you. So it's really not complicated if you follow. So, all right, here we are in Schoology. We are down in unit number 7 in week number 4, the 1st to the 4th of June. You'll notice we have the whole week lined up for us, and most of it will be from biodiversity directions down, our 4th and final state lab. But today, let's take a look at Loop Lake, which is number 57 right here. All right, now, once you click on that, you're going to get I don't need you, Cami Connect. You're going to get all kinds of pages. We're not interested in any of these until we hit page 7. These are all background direction type things. This is where we start. Now, Cami is great for this because we can draw directly on it, and you're going to see that's a thing that we need to do. So number 1, it wants you first to locate the contour lines of the map. These lines indicate the elevation of the land at a location. Since there are 10 feet between each contour line, comparisons with other elevations can be made. You count how many lines are between two places, 10 per line, and add them together. So first it wants you to do is place an X on the highest and lowest point of the map. All right, I'm going to do this in black. So what we want to do is we want to look around. Now, see, I see a 950 here. I see a 960 there, 950. Everything down here is down in the 800s. Let's see, over here is up to 930, 920, 930, 930, 920, 900. So this is lower than this, right? And so that 960 right down here is the highest point. Now, the lowest point. Okay, well, the lowest point, if we take a look, it's 900s on this side coming down in here. This is in the high 800s. We follow this. There's an 880. There's an 870. All right, so this is our lowest point. Now, locate the streams in the map. Streams always flow from high to low. Water moves downhill. How many streams are there? No problem. We come up the blue lines. So there's 1, 2, 3, 4, 5, 6, 7. There are 8, 9 total streams. Locate the stream that flows through the subdivision and mark its highest and lowest elevations with an X. No problem. We'll do this one in yellow. And we'll kick it more. So through the subdivision, here is the high point. And the lowest point is got to be, when it hits this line right here. What is the elevation of the high point of the stream and how many feet does it drop? All right, so if we take a look, you can see that this line comes through this contour line, which is 930, all the way down here to this one, which is 880. 880 to 930 is a 50-foot difference. So it goes from 950. That's the first answer. Why did I do that? Okay, can't explain it. And then how many feet does it change? What's it? No, it was 930, not 950. The difference was 50-foot drop. All right, Now it wants you to place a Y on the highest points of the streams that flow into Loop Lake. No problem. All right, so the high points are all going to be away. It'll be over here, right at those high points. Come on, there we go. Now there's one more right here. So those all flow into Loop Lake. These two on the side don't connect to it, so they don't have any point in this one. All right. Place a Z on the highest points above the streams. Okay, let's do this one in red. So now all these high points. So that's a high point. This is obviously a high point. Over here is one. Over here is one. You can generally tell them because they're going to have a full circle that you can see it come all the way back around. See how this one comes around? That means that it is a top area. All right, and we got one more down here. Fantastic. All right. Following the highest elevation, connect these Z's with lines. Great. We could do that. So Z to Z, Z to Z. Notice, doesn't need to be perfect. Now what we're doing, sure, it'll dip a little bit. Whatever, follows the road. All right, there we go. We've connected them with lines. Now this is a really important concept because what we just did here was we created the watershed for the area. And what that means is that everything within those red lines is a bowl. And as rain falls anywhere, it will flow down into the bowl, down into Loop Lake, which is the bottom of the bowl. All right, so that means that anything that is produced, if I dump a bucket up over here, it will flow down into that lake. If I dump a bucket over here, it will flow down into these lakes and streams. If I dump a bucket outside this watershed, it will not go into the lake. So if I take a big old blob of super hazardous waste, something really, really dangerous, and I put it here, that will go into the lake. But if I do it over here, it won't. They're in different watersheds. They will flow to different places. All right. So this outline encompasses all of the land that drains into Loop Lake. What is the name for an area that drains to one location? That is the watershed that I was just talking about. One stream serves as the outlet stream for Loop Lake. Locate it and name the business the stream flows through. How did you know that this was the outlet? Well, we come back up here. All these streams with those Ys are coming into it. What's the only stream that doesn't have a Y that connects? It's this long one right here. That must flow out. And you can tell because check the contour lines. The contour lines down here are 970. That's the lowest point, which means that from here to there, it goes down by 10 feet. So water will flow downhill out of the lake on this very slow, gradual stream. Now, what is the name of the business that it passes through? The Holstein Farm. So it passes through the Holstein Farm, and we know it's the outlet because the height decreases. All right. Now, using this information, you should be able to answer this first one. So, after hearing the story of the fish kill, Write whether you think the factory is to blame or not. All right, background for the lab here. It's earlier in the pages, but I'll summarize. The town got concerned because all of a sudden a lot of fish in that lake died. And they wanted to blame the factory because the factory just moved in. Factories make pollution. Pollution entered their lake, killed their fish. So what we did, this whole first part, was an ecological study to see what is the cause. And what we're able to ascertain is, number one, is the factory to blame? Yes or no? You should be able to answer it based on the information that we now have. Now, after that, they look into it even deeper, and there's this water quality. And we find out that what killed the fish was what we call an algal bloom, algae. Algae went crazy in the lake, lots and lots. Water got cloudy, lost a lot of its oxygen, and so the fish died. Now, they want you to predict for part 3. Why? Why would the algae go crazy? What caused that to happen? This is just your prediction. Doesn't need to be accurate. So write your predictions. Now, to finish up part 4, we need to use the water quality graphs sheet, which is right down here. And I'm going to show you guys how to do this. This is kind of like a graphing. All right, what you see here are all the businesses and stuff that are around or connected to Loop Lake. We're looking at dissolved oxygen, turbidity, whatever that is, fertilizers and nutrients. And what you see with the dot and the line is the state standards, New York State's standards for water cleanliness. So dissolved oxygen should be 5.0. Let me change this. Or higher. You can see right now it's at 3.1. That's why the fish died. There wasn't enough oxygen for them. Turbidity should be at 29 or less. We see that Loop Lake right now is at 56. Way, way, way up. Not where it should be. We see that fertilizers and nutrients should be 0.5 or lower according to the state. And instead it's 1, significantly higher. All right, so how do we get the rest of these points? You come down to this last page where we have our data and we take a look. So let's look at the Holstein farm. Dissolved oxygen is 8.7. So we come up to the dissolved oxygen one. Here's the farm, 5 right here. So 6, 7, 8, and 8.7 would be almost a 9, and we put a dot. You can see the farm is where it should be. It's 5.0 or above. All right, let's check turbidity. Come down here. Turbidity at the farm is 12. So farm 12 is going to be just about halfway between the two. Farm is also healthy there. What about fertilizers and nutrients? 0.03. So that's 1, 0.02, 0.03. So the farm is fine. All of its numbers are within the state standards for cleanliness and health. Let's look at the parking lot then. Dissolved oxygen is 5.6. So the parking lot, we come up, it's just barely in the acceptable range. Turbidity is 18. Well, 18 is still below 29, should be right somewhere in the neighborhood of that. Fertilizers, 0.1. Well, 0.1 is real low, so boom. All right, now we have all the dots for the parking. There's no line connection. You just want to, we've done this one. We've done this one. You just want to go through each of these and put a dot where it would be to determine where are these bad numbers coming from. Because if you take a look, remember, these are the state standards that we should have right here. But Loop Lake today is in a bad spot for all 3 of those. So we want to find out who is contributing, which businesses. So whichever one has dissolved oxygen really low, that might be the one that's responsible for the fish kill. but also look for who has really high turbidity that took part as well. Look for who has really high fertilizers and dissolved nutrients. They are involved as well. And then ultimately, in our last three questions, you will look through and see how many land uses around Loop Lake have fertilizer or nutrient levels that exceed the standards that are above that point. Mark it down. What about turbidity? Write an explanation for how algal blooms and fish kill occurred in Loop Lake. Now, this one gets a little bit more complicated, but I'm going to help you out because I am just such a kind individual. All right. If we increase fertilizers, it feeds algae to grow and reproduce. Use that knowledge when you're going through here to better understand how an algal bloom happens. Now, number 3, is it point or non-point? What this means is, can you point at the person responsible and say, you did it, you are responsible, you did something wrong? That's point pollution. Non-point pollution is exactly the opposite. There's no one person to point at because it wasn't the result of one person or one organization. It was the result of accumulated effects from many different polluting sites, I guess. So point pollution, they did it. Non-point pollution is lots of people did it. Ladies and gentlemen, I hope that helps. The lab itself is pretty quick, especially once we're through that. I hope that everybody has a good chance to take a look at it. And otherwise, I will see you in class.